Hey there guys, Coach Harris again. Got a 5-minute math lesson this morning coming from the garage in quarantine. So today we're going to talk about parallel perpendicular slopes, also parallel perpendicular lines. We're going to try to shove this all into a good 5-minute little session right here. So if I sound a little bit stuffed up because showing a symptom today, may go get my 14th COVID test or something like that. It'd actually be my 3rd. But anyway, so let's talk about this parallel versus perpendicular. Some thoughts here. All right, they never intersect. For parallel lines, they never intersect. They never meet, they never cross, no point of intersection. Perpendicular lines, they intersect at a 90-degree or a right angle. Okay, something to think about right there. The symbol for parallel lines is just like two L's, all right, two lowercase L's right next to one another. The symbol for perpendicular lines is an upside down T. If you want to just kind of throw the little box in there just as a little reminder that they do meet at a 90-degree angle, then that's something that's pretty valuable as well. The slopes themselves, I'm going to take that off right there. The slopes themselves, parallel lines have the same slope. And perpendicular lines have negative reciprocal slopes. Okay, so that usually is something that gives people a little bit of a difficult time. We'll take a look at that in just a moment. Now, for instance, if I had two parallel lines over here, if I had one that was y equals 3x minus 1, and the other one I had y equals something x plus 5, if it's going to be parallel, it has to have the same exact slope. So that value right there, that coefficient right there in front of the x must be the same. Again, that's where the slope's located in the slope-intercept form. Now, an example of negative reciprocal slopes, or perpendicular, would be y equals 3/2 x plus 2, and then y equals, now watch this, the negative reciprocal, what we're going to do is we're going to take that slope, we're going to invert it, okay, or create the reciprocal 2/3, and the negative of it just changes the signs. Okay, so these would be perpendicular sloped lines, or lines that are perpendicular to one another. Notice, this slope right here has been flipped, okay? And then also the sign has changed. Let's take a look at that. Let me turn the board around. Okay, so what if I said, let's find the perpendicular slope to this given line. So I've got y equals 6/7 x plus 5. Okay, well, my original slope, I pulled that out, is 6/7. So my reciprocal would be 7/6. And then the negative of that would just be to change the sign. Okay, so this is the perpendicular slope to the original. Okay, so I've taken the original slope, flip it upside down, or find the reciprocal, and then change the sign. All right, so let's put this in layman's terms to make it a little bit easier to remember. Negative reciprocal. Flip. Okay, negative. Change the sign. Okay, that's really all it's telling me to do. Now, one key thing here. What if I've got something like this? Y equals 7x plus 5. We very often do not think of this as a slope of 7/1. Now, it probably is a lot more helpful to go ahead and start to think of this as a fraction, 7/1. Two reasons why. Number one, it's easier to find the negative reciprocal if we're looking for the perpendicular. Also, it's easier to apply rise over run if we are graphing that. Okay, so hopefully that helps you guys out. This has been another little 5-minute math lesson with Coach Harris. We're talking about parallel, perpendicular lines, and then also the parallel and perpendicular slopes. Have a great day.